Hello everyone, welcome to my YouTube channel AB Classes. So today we are going to discuss about the mirrors formula. As I already discussed about the in earlier classes, I discussed about the spherical mirrors, poles, concave, convex mirror, image formation, Cartesian coordinate system, what is the image distance, object distance. So here we are going to discuss about the mirror formula. This mirror formula tells us about the relation between this focal length, image distance and the object distance. Okay, so let's start the derivation of it. See, this is the diagram in which it is a concave mirror. Okay, this is a object AB of height h1. Now we consider the ray which is parallel to this principal axis which passes through this focus, and second ray is the this one which incident on this pole and get reflected and intersect the previous one at this point A dash, and this is the image formation A dash B dash. Okay, so in triangle ABC and A dash B dash C, what we will see that this both triangle are similar. Why? Because this angle is equal to this and this is 90. So by angle criteria, triangle ABC is similar to triangle A dash B dash C. So A dash B dash upon AB is equal to B dash C upon BC. Now B dash C is what? This distance B dash C. So B dash C is equal to what? This CP minus B dash P. So CP minus B dash P upon this BC is what? BC is this distance. So it is equal to BP minus CP. BP minus CP. Okay. So A dash B dash upon AB is equal to what? See, as I already told in earlier classes that all the distance has to be measured from the pole. The distance which is measured in the direction of this incident ray is taken to be positive, and the distance which is measured against the incident ray is taken to be negative. Okay, see this CP is what? This distance which is the radius of curvature, and it is left, it is against this incident ray. That's why this R is taken to be negative, minus R. Now B dash P is what? This is the image distance. Image distance is taken to be negative, then it will become plus V upon BP. BP is what? This distance, that is the U. It is taken to be minus U, and minus CP. CP is what? Radius of curvature, which is taken to be negative, then it will plus R. Okay, so this is the first relation. Now you will see that in triangle APB and triangle A dash PB, this both are similar. Okay, then triangle APB is similar to triangle A dash PB dash. Okay, A dash PB dash. Now again A dash B dash upon AB is equal to what? B dash P upon BP. Now what is B dash P? B dash P is this distance, that is V, which is taken to be minus V upon what is BP? BP is this distance U minus U. So it is equal to V by U. Now from equation 1 and 2, 1 and 2, that left hand side are equal, then minus R plus V upon minus U plus R is equal to V by U. Doing cross multiplication, minus R U plus VU is equal to minus VU plus RV. Okay, RV. Taking this to right hand side, VU plus VU equal to R u plus v. Okay, this is 2vu. Divide both sides by uvr, then this become equal to 2 upon r is equal to u plus v upon uv. This is equal to 1 upon u plus 1 upon v. Okay, so from here, what is r by 2? This is equal to 1 by f. So 1 by f is equal to 1 by u plus 1 by v. This is the mirror formula. This gives the relation between u, v and f. Okay. Now another thing is that from this relation, see, from this one, this a dash b dash is what? H2. See, all the distance measured in downward direction is taken to be negative. So this is H2 and AB stay is H1. So this is equal to minus H2 upon H1, which is equal to what? V by U, or H2 by H1 is equal to minus V by U. And this ratio H2 by H1 is what we called linear magnification. It is denoted by M. H2 by H1, which is equal to minus V upon U. This is the linear magnification. Okay, so these are all about the spherical mirror, reflection of light. Now, our next topic is the refraction of light. So, refraction of light. See, in reflection of light, what we will observe that the incident ray strike on a opaque surface and get reflected in the same medium. But in refraction of light, what will happen that whenever a light ray passes from one medium to another, then it changes its path. See, like this one. See, this is some material and this is suppose air. Now, if light passes from this medium, air, suppose this is glass, then it will get reflected by this one. Okay, so this is the angle of incidence and this is the angle of refraction, sorry, and this is normal. So whenever there is two medium, one is this rarer medium, what is rarer medium, in which the density of particle is very low, and in what is denser medium, the density of particle is high. So in this case, this will the rarer medium, and this one is denser medium. So whenever light falls or travels from a rarer medium to a denser medium, it will change its path, and this phenomenon is known as refraction of light. Now, why this light has to change its direction when it passes from one medium to another medium? Why this phenomena occurs? This is because the light has different speed in different medium. In air, it has some speed. In vacuum, its speed is about 10 to 10 power 8 meter per second. In glass, it has different speed. So as light enters into this medium, the density of particle in this medium is very high, due to which it opposes its speed, and hence the speed of light reduces in this medium. Now, see, now as this particle enter into this medium, what will happen? This particle, the density of this particle is very high, due to which the particle in this medium opposes the speed of light. Now, this particle has to cover this distance in least time. See, this is the nature of light, that it has to travel a given distance in very minimum interval of time. So it has to change its path so that it bends toward this normal. Why it bends toward this normal? Because normal is the shortest distance of all the distance to which we have to be compared. Okay, so it has to bend in order to travel this distance in a minimum time, and this is the condition for the refraction of light. Okay, now laws of refraction. Laws of refraction. First law. See, this is the angle of incidence and this is the angle of refraction. So the ratio of this angle of sine of this angle of incidence to angle of refraction is constant for a given medium, and that is known as the refractive index of that medium. And we will write this refractive index in this form. The upper indices is what from which the air has to enter, and the lower indices to which the second medium. Okay, a mu z. See, so this is the property, and it is also defined as the velocity of light in air, that is Va upon velocity of light in glass. Okay, so these are all about the refraction of light. See, one thing is, again, the ray of light which entered into this material, if I place some mirror here, then it again retain its original path. That is, it retraces its original path. After striking this mirror, it gets reflected back by the same path that it has entered earlier. Okay, and that is what we call the principle of reversibility. So if we allow this light to get travel back, then it will retrace its path. So if we apply the Snell's law, and see, this is what we called Snell's law. Then what? Now this become angle of incidence and this become angle of refraction. Then sine r upon sine I is equal to what? Firstly, we have to write this medium, that is G mu A. Now, if we multiply these two equations, what we will get? That A mu G is equal to 1 upon G mu A. That is, refractive index of medium 2 with respect to medium 1 is equal to 1 upon refractive index of medium 1 with respect to medium 2, and this is the condition of reversibility, principle of reversibility. Okay, in next lecture we are going to talk about the refraction of light through a rectangular glass slab. What is the lateral displacement? What is emergent ray? So thank you.